Hi guys, the other day I was looking at this solar light set. It's stripped out of a solar flower pot. It's a sort of white plastic flower pot. The idea is during the day the solar panel charges up the batteries, and at night those LEDs illuminate the flower pot, so it goes through a light changing sequence, red, blue and green. If I just plug the battery in, there you go, red, blue, green, and then it actually cycles through a color changing sequence. Well, if I just cover the light a little bit, you can see it a bit easier. So that's working. The actual flower pot itself, because it had been in the sun for years, it had gone very brittle and basically fell apart, so I picked it up, which is why I've salvaged this stuff out of it. Anyway, yeah, that appears to work fine. However, what I noticed, if I take the battery out and halogen light on the solar panel, we're actually lighting the LEDs, and that shouldn't happen. If I just put the batteries back in again, okay, they're alight nicely. But if I bring the panel up, what should happen is the LED should go out, because the power should be diverted from the solar panel to the batteries, and it shouldn't be coming all the way through and lighting up the LEDs. So either the solar panel isn't working, but it is, because with the batteries out, we're clearly getting enough power going all the way through to light them up. So the solar panel's okay, but we do have this little circuit board here, which I think is the one that does the charge control. It's actually got H710 written on it. I don't know if that's particularly significant. Over there, that has, let's take the light out of the way so it's not quite so bright. That has H4709 written on it, and that has H4708 written on it. So H4708, H4709, and H4710. Don't know what the significance are. It's obviously the codes for the separate parts. What I thought I'd do today, though, is have a closer look at this, see if I can actually copy the circuitry down and see if I can work out what it actually does. Because I would have thought it should be stopping the power going straight the way through. It should be going directly to the batteries. So I'll do a close-up of that and then see if I can work out how the circuit actually works. I am not bigclive.com. I'm not good at trying to reverse engineer things, but there is only 2 transistors there, 4 resistors and 1 diode. So yeah, we'll see if we can draw a little diagram up, and then I'll let somebody else tell me what it actually does. I'm not going to try and do anything at that end. I'm assuming that that black blob just controls the cycling of the LEDs. It certainly can't be dealing with the charge control, because it's only got 2 wires going to it, so it can't be diverting stuff to the batteries. Now, one more thing before I forget. I did wonder, being as we've got 3 AA batteries, 1.2 volts each, 3.6 volts altogether. Freshly charged a little bit more. How about if we had a vape battery, 3.7 volts? If the charging circuit worked, would it charge a small LiPo? It's the right sort of voltage range. Obviously there's no protection there, but I'm just looking at would it actually work. If I put that down there, put that one on there, put that one on there, and put that one on there, and we have, let's just turn that light out. Yeah. So it's apparently running okay off the LiPo battery. It's the same sort of voltage, 3.7 volts, thereabouts, 4.2 freshly charged. So that would be an interesting little project if I can sort out what's happening with this charging circuit, whether we could charge a LiPo. Side issue, but it would be an interesting diversion. Anyway, we will have a look at that circuit and see if we can work out what it actually does, or as I say, if somebody could actually tell me how it works in the comments. I've taken some photos of the circuit board here so you can have a look at them. I've done a hand-drawn copy of it, and I've also had a think about it, and I've worked out how it works, and it was a perfect subject for trying out the Tinkercad circuit simulation app online. First time I've used it to do something useful. I've had a little play with it, but this is the first time I've tried to do something useful with it. I'm certainly no expert, but I will do a talkthrough of my Tinkercad simulation. Just very simply, that picture of a diode just there, that's where the LEDs are connected on the back. These two wires here are the ones going to the solar panel, and these two wires are the ones going to the batteries. At the moment, if we got power coming in on the solar panel wires, it's actually going through that diode there, through the LEDs, through that transistor, and back to the solar panel. So it's actually got a path all the way through to light up the LEDs. Normally, what should happen is when there's power on the solar panel, it switches that transistor on. When that transistor is switched on, it switches that transistor off so that the LEDs don't light up. And the power goes through that diode into the batteries. So it's going that way round. So what we must have is one of these resistors, or even that transistor is faulty. That you can see they've got rusty legs, so it could be anything along that lines. It could be any of them have gone rusty and high resistance, and that's preventing the solar panel switching that on and switching that off. So what actually happens is power comes in there, whether the batteries are there or not, it comes through that diode up here. That picture of a diode there is actually where the LEDs are connected, so it goes through the LEDs, through that transistor and back down to the negative. So that's what's happening at the moment, because that transistor is not switching that one off. And as I say, I'll do a talk through on the Tinkercad simulation on a separate video, because this one's gone on long enough. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.